Sketch the graph of y equals 2x plus 1 over x plus 1 on the axes below. Now it's a calculated paper, so we can have a good look at what it looks like. So let's go to graph and table and let's put this equation in. So it's 2x plus 1 over x add 1. Let's graph it. Let's get some suitable axes. So let's just use what we've got here. So negative 0.5 through to 3.5. And let's go from negative 0.5 up to 2.5. Here it is. We can see the intercepts at 1. That was easy enough to work out. Just put x equals 0. It seems to intercept at this point here. We can always check that out as well. And it seems to be going over towards 2 like so. We now want to use Simpson's rule with n equals 6, so that's 6 strips to approximate this one. So let's have a look at our x values. So that would be 0, x1 would be 0.5, x2 will be 1, x3 will be 1.5, x4 would be 2, x5 would be 2.5, and x6 will be 3. So that's our 7 ordinates giving us 6 strips. So we now want the corresponding y values. So y0, y1, y2, y3, y4, y5 and y6. And of course we can use the calculator to produce these very quickly for us. So we're already in graph and table, which is great. So with the same function I'm going to produce a table, and we're going to start the table at 0 and we're going to end it at 6, and actually we'll end it at 3. That's the end of the integral, and with a step of 0.5. And so here's our values. So we've got 1, 1.3 recurring, 1.5, 1.6, 1.6 recurring, 1.7143, and we want the final answer to 4 decimal places, so I might just 1.714286 might be a bit better, and that one seems to be exactly 1.75. So all we need to do is apply the Simpson's rule formula. So h is the gap here, so that's 0.5 over 3. And then we want the first and the last value of y, so that's the 1 plus 1.75. And then we have twice the even numbered coordinates, so that's twice, so that's the even ones apart from the 0 and the 6 obviously. So that's going to be those two, the 1.5 add 1.6 recurring. And then we have 4 times the odd ones. So in that case that's going to be this one, and this one. So 1.3 recurring and 1.6 and our 1.714286. So we just need to calculate this. And so if we go to main, let's just clear a bit of space here, and we have 0.5 divided by 3. Let's put the 3 on the bottom here. And then we've got, so we have the 1, add the 1.75. And then we've got twice 1.5 add 1.66666, and then we've got 4 times 1.333333, add 1.6, add 1.714,286, and just execute that, and that gives us, we want 4 decimal places here, so 4.6123. Determine the exact value of the integral and then calculate the percentage error. It's only 2 marks, so we can do the integral directly on the calculator. So we're doing the integral from 0 through to 3 of 2x add 1 over x add 1 dx. So integral from 0 to 3 of 2x plus 1 over x plus 1 dx is equal to 4.6137, and so on. And so our percentage error is going to be 4.6137 and so on. Take away the 4. Tidy that up. 4.6123 and so on, all over the exact value multiplied by 100. So on the calculator we can do that easily enough. We'll just take that and subtract that from it, and divide by that, and then multiply the result by 100, and we get 0.03%.